Okay. Hello, my name is Dimitris Batsis. I'm a postdoctoral researcher at the Department of Fine Arts and Art Sciences at the University of Ioannina, and I'm here today to present binaural audio in XR creation and beyond. So let's start with the basics. Hearing. Hearing is one of the five senses. Its perceptive organ is the ears, while the medium of perception is sound. It is considered the most important of the other senses because it helps perceive the exterior of a space immediately, while it facilitates communication and knowledge processes. Hearing contributes to the perception of space and complements the vision. There are cases when it satisfactorily replaces it in blind organisms and the bats. The German philosopher Immanuel Kant emphasizes the loss of sight removes humans from objects, while the loss of hearing removes humans from people. How hearing works. Hearing is always strong, active, as opposed to sight. Sound is produced mainly by living organisms, either by their respiratory system and their larynx, vocally, or because of their movement. Thereafter, a part of the sound reaches the ears. There, the sound waves are smoothed out and amplified appropriately so that the wave of specific location and space propagates to the cochlea. There are many suitable vibration receptors in the cochlea, which help the perception of pitch and acoustics. These receptors are activated depending on the pitch and acoustics of the sound and send electrical impulses to the brain. All these stimuli form an indefinite sonic composition. From these sounds, the brain undertakes to isolate a few, 3 at most. The sound sent by each ear is slightly different and helps to perceive the distance with the method of triangulation and generally to have a three-dimensional perception of sound sources and space. Hearing and sound. In opposition to sight, in hearing, the ear captures all kinds of frequencies and does not construct an acoustic image of the world from a few specific frequencies. The total frequency of the mechanical waves of the environment that a human being can hear is called sound and has a frequency of 15 to 20,000 cycles per second. Waves such with higher frequencies are called ultrasound, while the ones with lower frequencies are called subsonic. Other organisms can perceive sound of different acoustics and different frequencies. There are also organisms that perceive ultrasound. For example, the bat relies more on hearing than sight. It can hear 2 people whispering in one corner of a football field while it is located in the other. Perception of space. Hearing is directly related to the perception of extracorporeal space, and especially its three-dimensional perception. The comparison of the sounds heard from both ears helps to locate the type of their source and to calculate the source's distance through triangulation. According to this method, which is also used in sciences such as topography, there is an imaginary triangle defined by both ears and the object. By knowing the distance of the ears and the directions from which the ears hear the object, we can calculate the distance between the object and the face. sound diffusion through technological systems. With the surround system, it is possible to have sounds coming from about 4 usually directions. In comparison, 3D audio allows the listener to perceive sound from any direction, including points above and below it. In addition, the best 3D audio technology allows listeners to accurately pinpoint the direction of the sound. Spatial sound. Spatial sound is quite similar to what we hear in real life. It has an immersive ability for the listener compared to the typical stereophonic sound. 3D sound is essentially the virtual reality of hearing. The goal of 3D or spatial sound is to fully reproduce sound environments or compose utterly new ones. Like this one. With conventional stereo techniques, the diffusion of the sound is essentially limited to the space between the left and right speakers. Though 3D audio techniques aim to highlight the perception of sound from any and all directions by adding more channels or through signal processing. Binaural head. A pair of microphones inside a head form is used to record binaural sound. The polyester head, which is converted through rubber addition during the production process to a durable material, and silicone ears with microphone capsules can be used for testing. Specially designed head models, such as this one, are used in production. Binaural hearing. The main difference between the two ears is that they are not positioned in the same place. The use of both ears to perceive the various sounds around us is defined as binaural hearing. It could be said that in the manner that we use 2 eyes to see in 3 dimensions, we use 2 ears for dimensional hearing. Binaural hearing is exactly the opposite of monophonic hearing. It enables us to map the sound in space, to perceive softer sounds, to perceive distant sounds, and even to separate the sound of a single voice from the environmental noise. Among mammals, humans are considered to have the most developed communication skills. One of the key factors that strengthens humans with the ability to communicate is spatial hearing. Spatial hearing provides indications about the relative number and location of sound sources and objects in the environment. It also helps to determine the dimension and characteristics of rooms and indoor spaces and contribute to the cocktail party effect, with which listeners can hear against other intrusive voices in crowded listening environments. A virtual representation gives the impression that the listener is constantly surrounded by a spherical distribution of speakers, firmly centered and oriented to his head. Utilization of binaural acoustic perception through ambisonics technology. For commercial use and playback, the basic difference is that binaural playback requires headphones, while ambisonics technology can be decoded into an array consisting of speakers. Summing up, we could briefly say that binaural acoustic perception and ambisonics technology are an integral part of virtual, augmented, and mixed reality exclusively or as a combination of the 3, better known as extended reality. Thank you.